Yes, am I audible?
Yes, sir.
Okay. But there is one problem. My writing pad is not working today, so I can speak, but I can't write anything. Like I'm trying to write, but it's not working. So I'm just trying. Give me 5-10 minutes if I can work out something. Just give me 5-10 minutes. My writing pad is not working. I can't write anything. Okay, so let's try to take this class without the writing pad. So those who have joined just now, my writing pad is not working. So I'm taking the class, but I can't write much. So I'll be using the slides only. Yeah? So let's see how long can I take without without writing anything. So what was the last numerical that we did? We have finished lens maker formula. So what was the last question that we did?
Complete the ray diagram if
Okay, we did
N2
this one.
greater than N1.
Okay. So we did this question with the concave lens, and I asked you to repeat it with convex lens also. You can repeat the same question with convex lens. The next question is on sunglasses. See, if you have a lens which have a curvature, then that lens should have a definite focal length, right? If you have a lens which have a curvature means if you have R, then that lens should have a focal length. And if it have a focal length, then that lens should have a power. Does anyone tell me the relation between power and focal? Does anyone know any relation between power and focal length?
Power is equal to 1 by focal length.
Yeah, power is 1 by focal length. The inverse of focal length is power. Just give me 1 minute. Yeah, power is 1 by focal length. Huh? So if I'm taking a lens which have a curvature, then spherical lens, that lens should have a definite focal length and it will have a non-zero power. But if we talk about sunglasses, sunglasses are spherical lenses. But what is the power of sunglasses? It's zero, right?
Yes, sir.
We use lenses because they have power. That means the lens that I'm using, it has some power. It has some non-zero focal length. But when you use sunglasses, sunglass doesn't have any power. The power of sunglass is zero. The power of sunglass is zero. That means the focal length of sunglass is infinite. Power and focal length are inversely proportional. So let me write using the writing pad. Okay, I'm writing with the mouse pad. I don't know how. Yes. So power is 1 by focal length. So if power is 0, then what about focal length? How much is focal length now? If P is 0, then how much is F?
Infinite.
Yeah, F will be 1 by 0. And how much is 1 by 0? 1 by 0 is infinite. If you take it is 1 by 0. And 1 by 0 is infinite. So if you have a lens having 0 power, that means its focal length should be infinite. So the question is a very interesting question. What happens with a sunglass? Your sunglass have a spherical surface, a spherical lens, but still its power is 0, means focal length is infinite. So how we make a sunglass? So in sunglasses, what we do is we use a convexo-concave lens. So in sunglasses, power is 0, that means focal length should be infinite. So what are sunglasses? Sunglasses are just a convexo-concave lens. Convexo-concave lens means one lens is convex, the one surface is convex, another surface is concave. So for the first surface, this is the center of curvature. For the second surface, this is the center of curvature. So if you write sign convention, then you can say that R1 is equal to plus R and R2 is also equal to plus R. So this is R1. You're going in the direction of light, right? So both are positive. R1 is plus R and R2 is plus R. What is lens maker formula, Arpit? Lens maker formula. Arpit. Arpit तो सुनता ही नहीं है. Krishna, what is lens maker formula?
Sir, minus N2 by U plus N1 by V is equal to N2 minus N1 by R.
No, no, that's not lens maker formula. That is the formula for spherical refracting surface. That's not lens maker formula.
1 by F is equal to 1 by R.
No, that is for mirror. It's not for lens. Akshay, lens maker formula. Lens maker formula, Akshay. Saifullah, lens maker formula.
1 by F equals to N21 minus 1 into 1 by R1 minus 1 by R2.
All right. So that's lens maker formula. Now, 1 N21 minus 1, 1 by R1 minus 1 by R2. See, both R1 and R2 are equal. So instead of R1, you can write R. R2, you can write R. See, these terms will cancel each other. Huh? So your 1 by F comes out to be 0. Your F comes out to be infinity. So what is sunglass? Sunglass consists of a convexo-concave lens having equal radii of curvature. So that you have a spherical surface, but still the power is 0. Basically, you can say the power of this surface cancel the power of second surface. Is it clear, everyone? Yoshika, Munib.
Yes,
Yes,
sir.
sir.
So it's a
Yes.
very general question that why a sunglass have 0 power, still it's a spherical lens. So it's a convex or concave lens having equal radii of curvature. Please note it down. We'll do the next question. Tell me once you have written. I'll do the next question. Can I scroll it if you have written?
Yes, sir.
Just a minute.
1 minute, sir. Yes, sir. Then
So what is the radius of curvature of a plane surface? If I have a plane surface, like I have a surface like this. This is a plane surface. So what is the radius of curvature of this surface?
Infinite, sir.
Infinite.
0.
So no, not zero. Zero radius of curvature means you're making a point. So the radius of curvature of a plane surface is infinite. You can assume like plane surface is a part of a sphere having infinite radius. So we'll use plane surface and cutting off lens. Next, you have questions on cutting off lens. He'll give you a lens having some radius of curvature R1 and R2. We can consider that this lens is an equiconvex lens. This is an equiconvex lens. Sorry. This is an equiconvex lens. So equiconvex lens means a lens which have radius of curve for which both the surfaces have same radius of curvature. First surface and second surface, R1 or R2 is equal. So this we have discussed in the last class that if you have a convex lens, then R1 is positive and R2 is negative. So R1 is plus R and R2 is minus R. And this is the lens maker formula. So I'm substituting R1 equal to plus R and R2 equal to minus R here. So what I get is 1 by F is N2 by N1 minus 1. 1 by R. Instead of R2, I'm substituting minus R. So minus of minus 1 by R. So it becomes 2 by R. Is it clear, everyone, up to equation number 2? Miraj?
Yes,
yes, sir.
Okay. So I just substituted the value of R1 and R2 equal to R and minus R. So that's 1 by F, which is N2 by N1 minus 1 into 2 by R. The next is, he will ask you to cut the lens. You can cut lens in two ways. You can cut the lens. This is principal axis. This is principal axis. So you can cut the lens. This is principal axis. So you can cut the lens perpendicular to principal axis or parallel to principal axis. So currently we are cutting this lens perpendicular to principal axis, like in this way. We are cutting this lens. So when you cut this lens perpendicular to principal axis, it divides into these two lenses. So it's not a convex lens now, right? One surface is convex, another surface is plane. So you have a plano-convex lens now. So if you take a convex lens and you divide that lens into two parts, then the two parts are now the convex lens. But it's, sorry, not the convex lens. You have two plano-convex lens now. Now the question is, if the focal length of equiconvex lens is F, then what about the focal length of this particular lens or this lens? You have to calculate the focal length of one lens. So to get the focal length of one lens, what you can do is, again, we'll apply the lens maker formula. And what is the focal length of the second surface? Miraj, what is the focal length of this surface? This plane surface. Sorry, radius of curvature of this surface, this plane surface.
Sir, F.
I'm asking radius of curvature of the plane surface. Anshika, what is the radius of curvature of the plane surface?
Sir, 0.
Not 0, we just have discussed. Sakina, what is the radius of curvature of plane surface?
Infinity, sir.
It's infinite. We discussed it just now. If you have a plane surface, its radius of curvature is infinite. So the first surface is curved surface. Its radius of curvature is R. But for the second surface, the radius of curvature is infinite. So when you put here, R1 is R, R2 is infinite. 1 by infinite is 0, so it's 1 by R. So if I compare this from this, this is equation number 2, and this is equation number 3. This F is the focal length of your equiconvex lens. And this is the focal length of your plano convex lens. Miraj, can you compare these two equations, 2 and 3? Which one is greater? 2 is greater or 3 is greater? Miraj, think.
Sir, 2 is great. No, sir, 3 is greater.
3 is greater. Akshay, what do you think? 3 is greater or 2 is greater? I'm asking about f and f prime. F is greater or
Sir,
f
2
prime?
is greater, sir, because 2 by r and 1 by r.
Akshay. Okay, Miraj, you're saying 2 is greater. Like you're saying f is greater than f prime. I'm asking
Sir,
again.
F prime is greater.
F prime is greater. See, this is here it is 2, here it is 1. It is greater, but f is in denominator. 1 by f is greater than 1 by f prime. So if you want to just see comparing, you can say that this 1 by f is the double of this thing, right? Equation 2 is double of equation 3. If you multiply equation 3 with 2, you get equation number 2. So you can say 1 by f prime is twice of 1 by f. Sorry, 1 by f is twice of 1 by f prime. So you can say that f prime is equal to 2f. Again, see. This is equation 3 now. So if I multiply equation 3 with 2, you will get equation number 2. So on multiplying this with 2 means on multiplying 1 by f prime with 2, you get 1 by f. So you can say if you cross multiply them, you say that f prime is equal to 2f. So if you take a lens, cut that lens into two parts perpendicular to principal axis. So the lenses that you get plano-convex lens, they have the focal length of that particular lens is double to that of your equiconvex. Is it clear?
Yes, sir.
Yes, sir.
Fine.
Yes, sir.
There's one more question. He asks you, okay, if you take a convex lens and you cut that convex lens parallel to principal axis, you take a convex lens, you cut that lens parallel to principal axis, then what will happen with the focal length? Now think in this way. On cutting a lens parallel to principal axis, you get this thing. Does radius of curvature change or it will remain same? Cutting a lens in this way. The radius of curvature will remain same. See, radius of curvature is not changing. The refractive indices is not changing. So focal length depends upon the radius of curvature. It depends upon the refractive index of the lens and the surrounding. So neither the refractive index change nor the focal length change. Oh, sorry, radius of curvature change. So there is no change in focal length. So if you take a lens, cut it parallel to principal axis, the focal length will not change. Focal length will remain same. But yes, the intensity of light will change. In fact, intensity of light will get halved. So if you have a lens, you cut that lens into two parts, the intensity of light gets halved. Intensity of light gets halved means only 50% of light can enter, right? You have a 50% lens now, so only 50% of light will enter. How that will affect your image? That will decrease the brightness of the image. The brightness of the image depends upon the amount of light that is entering in your lens. So if you cut a lens into two parts, then the amount of light entering in the lens will be halved. So the intensity of image will reduce, but focal length will not change. It will reduce by half exactly. The brightness will reduce by half. So it's a very common question in cutting of lens. You take a lens, if you divide that lens into two parts, what happens with the focal length? If you cut a lens perpendicular to principal axis, you get a plano-convex lens and its focal length will get doubled. But if you take a lens, you cut that lens parallel to principal axis, then nothing will happen. Focal length will not change, but yes, the intensity will reduce. Note it down. And tell me if you have any issue with this. Kishma, is it clear?
Yes, sir.
Yes, sir.
Always remember this thing. If you cut a lens perpendicular to principal axis, then its focal length will get doubled. If you cut a lens parallel to principal axis, its focal length will get halved.
Sir, you said if we cut it parallel, its focal length will remain the same, right, sir?
Yes, sorry, yes, focal length means intensity will get halved. But if you cut it perpendicularly, then focal length will become double. Can I scroll it?
Yes, sir.
Miraj, is it clear how this focal length will become double?
Yes, sir.
सर एक बार ये समझा दो, इसका रेडियस और ये फोकल लेंथ डबल।
हाँ, which कौन सा वही?
सर एक बार ये वाला समझा दो, उसकी फोकल लेंथ ऐसे 2f क्यों हो गई?
So is it clear, this expression, this calculation?
सर कैलकुलेशन क्या है?
It's n2 by this is lens maker formula, na? N2 by n1 minus 1, 1 by r1 minus 1 by r2. The second surface is a plane surface. The radius of curvature of the second surface is infinite. So in lens maker formula, this lens maker formula, right? Here I just substitute that r2 is equal to infinite. This step is
सर
clear?
पर जब उसको स्प्लिट करा तो फिर 2f कैसे हो गई फोकल?
Coming to it. So this is n2 by n1 minus 1 into 1 by infinity is 0. So it will be 1 by r.
यस
Now, just compare equation number 3 and equation number 4. What's the difference between 3 and 2? This 2
सर
and this 2.
2 यस।
So can I write that 1 by f is twice of 1 by f prime? Like, can I write that equation 2 is twice of equation 3?
यस सर
So can I write 1 by f is twice of 1 by f prime?
यस सर
So then you cross multiply them. It's clear now?
यस यस।
Can I scroll it now? Written?
Yes, sir.
So the next test will be of chapter 4.
Hmm? What up it? Okay, I can scroll it now. So this is the last question on lens maker formula. So
Sir,
you
1
have a,
minute, sir.
okay.
Yes, sir, done.
So you have a lens. This lens have four medium, N1, N2, N3, N4. So he's asking how this lens will behave. So this single lens will behave like four lenses. So each medium will behave as a lens. So you have four mediums having different diffractive indices. So you have four lenses here. So you'll have four images, four focal length, four lenses, four images. That's it. That's the answer of this question. So if you have a system having n refractive indices, that means that system will behave like n lenses. That system will have f focal, n numbers of focal length. So if you have a single object, then you'll have n number of images. Note it down. It's again a conceptual question based on that.
Sir, it will have,
It
what
will
is the
form
third line, sir?
as many images as there are different ends. Sorry. You'll have many focal length and it will form as many images as there are different ends. So if you have n refractive indices, you will have n images. So it's the system is behaving like n lenses. Okay, written. So that was about lens maker formula. The last topic in refraction is the lens formula. The lens formula was there in class 11th also. We'll derive it, but this is at least the theory and the derivation is just the exact repetition of class 10 syllabus. You will have combination of lens, which is something new, but up to the derivation, it's completely the class 11 syllabus. So what is lens formula? It's just the relation between the object distance of the lens, the image distance of the lens, and the focal length, 1 by v minus 1 by u is 1 by f. And again, this is a general formula, which means it's valid for all type of lenses. How many type of lenses we studied in lens maker formula, Nazia? How many type of lenses we studied in lens maker formula?
We studied 6 types of lens.
6 type of lenses, very good. So this lens formula is valid for all 6 type of lenses. So it's a general formula and it's valid for all type of images. You can have a real image or you can have a virtual image. You can have a real object and you can have a virtual object. So it's valid for everything. So this is sort of general formula. So when you use general formula in numericals, you have to use sign convention. The next thing is with the magnification. What does magnification mean? Magnification is simply the ratio of height of image and height of object. We have various types of magnification, but currently we'll focus only on the linear magnification, which is in NCERT. So linear magnification is the ratio of height of image and the height of object. See, we can take the ratio of length also. Length, which is parallel to principal axis. That will be some longitudinal magnification, not coming to it. We need just height of image by height of object. When we say height, that means something which is above the principal axis. Along the principal axis is not height. Along the principal axis is length. When we say height, it's perpendicular to principal axis. So we have various formula for the magnification, height of image by height of object. And we can write it as v by u. Or this v by u can be written as f by f plus u or f minus v by f. So these are different relations for the magnification. And again, these relations are general relations. When you use this in numericals, you have to use sign convention. See, if you have m magnification, if you have m, If you know the magnification of any lens for a particular object, that means you know everything about that object, about that image, sorry. So what are the characteristics of an image in which we are interested? We are interested whether your image is magnified, means your image is greater than the object, or your image is diminished, it's smaller than the object. We are interested in the fact that whether your image is erect or your image is inverted. We are interested in the fact that your image is real or your image is virtual. So real image means the point at which rays actually meet, and the virtual means they diverge, and when you produce the rays, they appear to meet at a point. We'll see how we make the virtual images. And so if you know magnification, you know everything about the image. See, if your magnification is negative, that means your image is inverted. It is below the principal axis. So the negative sign will tell you that image is inverted. And if your image is inverted, then it's always real. So just the sign of the magnification will tell you that your image is inverted and it's real. If the sign is positive, that means your image is erect. And if it is erect, then it's virtual. So erect and virtual, inverted and real. But remember, this real and inverted, erect and virtual is valid only if your object is real. But if you talk about some virtual object, then for a virtual object, you can have a real image which is erect. You can have a virtual image which is inverted. But right now, all our discussions are for a real object. So if you have a real object, then your image is inverted and it's real also. If you have a magnification to be positive, that means your image is erect and it's virtual also. So remember, for a real object, real is inverted, virtual is always erect. Next, that was about the sign. Now see the magnitude of M. If the magnitude of M is greater than 1, that means your image is magnified. If the magnitude of M is less than 1, that means your image is diminished. It's smaller than the object. So just the magnitude of M will tell you many things. If it is greater than 1, that means you have a magnified image. If it is less than 1, that means you have a diminished image. Image is smaller than the object. So this is what you can decide if you have the magnification. So let's take this example. The magnification of the lens is M is equal to -3. M is equal to -3. So Hishma, what can you conclude about the image? If it is M is equal to -3, it's real, inverted, it's greater than the object or smaller than the object.
It's smaller and real.
It's real and
And it's
diminished.
not diminished. M is greater than 1. See, we don't, when we compare M, we don't see the sign of M. We just see the magnitude of M, mod of M, 3, which is greater than 1. So it's not diminished, it's magnified. So minus and plus will tell you whether image is real or virtual. It won't tell you whether it is magnified or it's diminished. It's mod of M which tell you whether it's magnified or diminished. So mod of M is 3. So 3 is greater than 1. That means your image is magnified with respect to object. Is it clear, everyone? Anshika, Noah, Jessica, Munib?
Yes.
Yes, sir.
Yes, sir.
Okay, just
So,
note. Yes.
Yes,
so
that's clear.
is it always necessary if the image is inverted, it will be real?
Yes, if your object is real. In 99.9% cases, we deal with the real object. But if you have a virtual object, then you can have a real image which is erect, or you can have a combination of erect and inverted and erect image. That's for the virtual object only. And what happens with a virtual object that can't be predicted just by looking at the diagram? You have to work out the lens formula also. So in 99.9% cases, real is inverted, erect is virtual. But for few cases where object is virtual, real can be erect. Can I scroll it? We'll
Yes,
derive
sir.
these relations, huh? Lens formula, the formula for magnification, this will derive.
Sir, the derivation of this is still important. So because we did this in earlier in junior classes.
I don't know. Yeah, if you look at the previous year's question, then they have asked this derivation. Not many times, but maybe in 10 years, 1 or 2 times. So you can't skip it. It's very, very easy derivation. So there's no point in skipping it. But the important one is Lensmaker formula and the derivation for the spherical refractive. And one more thing, if you want to prepare for CUET or for your NEET exams, the syllabus is same. The questions that I'm taking are mostly the previous year's questions of entrances also.
Sir, minus V by U नहीं आता?
No, minus V by U is for mirror reflection. In reflection also we have magnification. So that's for mirror, not for the lens. So you can remember it in this way. For lens, the lens formula is 1 by V minus 1U 1 by F, and M is V by U. For mirror, it's 1 by V plus 1 by U. So positive in mirror formula and negative sign in magnification. In lens, it's all.
Sir, could you just call up for a minute? Done, sir.
Written?
Yes, sir.
Okay, so to derive lens maker formula, the derivation is very easy. Let's start with the convex lens. So this is a convex lens. Let's take one ray one by one. This is first ray, which is parallel to principal axis. So ray number one, this is the first ray, which is parallel to principal axis. This is your object AB. This AB here is your object. So from point A, one ray is going, which is parallel to principal axis. After refraction, this ray will pass through the focus. This is the focus of the lens, right? This is the focus. So ray will pass through focus. Another ray is passing through this second ray. It's going through the optical center O here. And this ray will go straight. The ray passing through the optical center will not refract, will go straight. So both the rays will meet here. So rays are actually meeting over this point. So this is your image. It's a real image. So at the point where the rays actually meet is the real image. So this is the real image. The object is AB and this is A prime and this is B prime is your final image. The height of the object I am taking as H0. The height of the image is HI. So Arpit, is this image inverted or erect?
So can you repeat the question?
This image A prime B prime is inverted or is it erect?
Sir, it is inverted.
So it should be real or virtual?
Sir, it is real.
It's real. And you can see by the ray diagram also, the rays are converging. Rays are actually meeting over the point. So A prime, B prime should be a real image. AB is object. So O to B is the object distance U. And what is OB prime? Anshika, what is OB prime? If I'm going from O to B prime, what is OB prime, Anshika? I'm going from O to B prime, Anshika. What is OB prime?
Sure, B. V.
V. And what does V means? Image. Huh?
Image distance.
Yeah. So your AB is your object and the image is A prime, B prime. So the distance between the center of the lens and A prime, B prime is V. That is your image distance. And this is your object distance U. And the focal length of the lens is F. F is the focal length of the lens. So you have to relate this object distance, this image distance, and the focal length. So I'm repeating again. What is OB? OB is your object distance, which is U. What is OF? O to F is the focal length. Is this first focal length or the second focal length? Yashika? OF. Is it the first focal length of the lens or the second focal length?
Sir, first.
No. OF. First focal length or second? Second focal
Second
length.
focal length.
The point at which parallel rays converge is second focal length. The first focal length is the position where if you place your object, then after refraction, ray will become parallel. So the point at which parallel rays converge is the second focus, the second focal length. Okay, then I drop a perpendicular CO here. So the CO is equal to AB and AB is object. So see the height of CO is equal to the object. Let's see if we can find some pair of similar triangles. See this triangle ABO and triangle O prime, A prime, B prime, O. Hishma, can you find two angles which are equal in this triangle ABO? See, one triangle is this A, B, O. Another is this O, B prime, A prime. This triangle, huh? This one. Hishma, can you find any two angles which are equal in this triangle? ABO and A prime, B prime.
Angle ABO and OB prime A prime is equal.
Why?
90 degrees.
90 degrees. See this angle and this angle, they are 90 degrees.
And angle AOB and B prime O and A prime are equal because
Very
they are
good.
vertical.
Yeah, these two angles and these two angles are also equal. They are vertically opposite angles. So if two angles are equal, that means third angle will also be equal. So these two triangles are similar. These are similar triangles. So if you have similar triangles, then you can take the ratio of sides. You can say A prime B prime by AB. A prime B prime by AB will be equal to OB prime. So the side corresponding to OB prime for the first triangle is, which side is corresponding to OB prime in the first triangle? Is it OB or OA? Akshay, which side is corresponding to OB prime in the first triangle, in this triangle?
OB.
OB. So when if you have similar triangles, what we do, we take ratios. Huh? So I'll take ratio of A prime, B prime, and AB, and we'll take ratio of OB prime and OB. So A prime, B prime by AB is OB prime by OB. That's my first equation. Is it clear? The first equation. We just use the
Yes, sir.
property of similar triangles. If two triangles are similar, then the ratio of their corresponding sides are equal. So corresponding to A prime, B prime, we have AB. Corresponding to OB prime, we have OB. So A prime, B prime by AB is OB prime by OB. The second is, if we take another triangle like C, let's say this pair of triangles. This is C. Let's take different. So C, O, F, this triangle, and A prime, this A prime, this A prime, this B prime, and this F. These two triangles are again similar. See, this angle is 90. So this is also 90 degree. These two are vertically opposite angle like the previous case. So if two angles are equal, that means third will also be. Let's take the ratio again. A prime, B prime, and CO will be equal to FB prime by FO. See, FB prime, then OF. This side, FB prime, and this side, OF. So I'm taking the ratio. Now there is one problem with this. So first thing is CO is equal to AB. CO is just equal to AB. So I put C equal to AB. So I get A prime, B prime by AB is this. There is one problem with this equation. All sides should be measured from O. The starting point for measuring all distances should be O. But if you look at this thing, FB prime, the starting point is not O, starting point is F. Right? Starting point for all distances should be optical center. But when you look at FB prime, the starting point is not the optical center, starting point is F. So somehow you have to convert FB prime in terms of distances from O. Unib, can you write this FB prime distance in terms of two distances which are measured from O?
OB prime
F plus something.
No. F
OB
plus
prime
whatever.
minus OF
OB prime?
minus OF.
Yeah, minus OF. Right, Unip? If you take OB prime and you subtract OF from it, then you get this thing. If you add something to F, then you won't get FB prime. No, FB prime is this much distance, this much distance, this distance. So what you can do is you can take OB prime, then you subtract OF from it. So what I did, I just substituted the value of FB prime, OB prime minus OF by OF. Now just substitute the values. What is OB prime here? What is OB prime here? Nabil.
Object distance, image distance V
Image minus V plus V.
is plus V, sir.
Plus V. We are going in the direction of light, so it's plus V. So yes, it's plus V. And what is OB? We are going in a direction opposite to that of light. That's object distance minus U. So OB prime is plus V is minus U. And OF is a convex lens. So second focal length is positive. It's plus F. Now just substitute the value. Instead of OB prime, I substitute V. Instead of OB, I write minus U. OB prime, we write V minus V. OF is F. OF is F. Now we can just cross multiply them. When you cross multiply them, you get this thing. Just the numerator. Don't look at the denominator at least for the timing. You'll get VF. You multiply it here, you get minus UV. You multiply it here, you get UF. This is lens formula, but just to bring this formula in the standard form, we divide the whole equation with UVF. We're dividing both the parts by UVF. So when you divide both the parts by UF, you can see this VF and VF will cancel. UV will cancel. UF will cancel. So what term left here in the first equation? Anshika. Which term left in the first equation? Yes, Anshika, what terms are left in this equation? After dividing with UVF, what terms left? Anshika, I can't hear you. Akshay, what terms are left in this equation?
1 by U equal to minus 1 by f plus 1 by v.
Very good. The 1 by u is minus 1 by f plus 1 by. If you take 1 by f to the left hand side and 1 by u to the right hand side, you get this equation. 1 by f is 1 by v minus 1 by. Is it clear? Krishna, Ishma,
Yes,
Nazia,
sir.
Sakina.
Yes, sir.
Okay. Although it's not a very, very important derivation because you have done this thing in class 10th also. But the relation is important. You may get questions over it.
Sir, could you scroll up? Done, sir.
Okay. Can I scroll it now if you have written up to here?
Yes, sir.
Yes, sir.
So from this first equation, we can calculate the formula for the magnification also. What is A prime, B prime? Is it height of object image? What is A prime, B prime? Yes. What is A prime, B prime here?
Image height.
Height of
Image of
image.
height. So that will be positive or it should be negative. See, image is inverted. Huh? If a height is below the principal axis, then we take that height to be negative. So we will take this A prime, B prime to be minus. And AB is above the principal axis height of object, we take it as positive. OB prime is plus V, OB is minus V. So when we write it, we get HI by C, minus of HI by H naught. Instead of A prime, B prime, I'm writing minus of HI. Instead of AB, that's height of object, I'm writing H naught. OB prime is plus U and OB is minus U. So if this negative and negative gets cancelled out, height of image by height of object is V by U. So you can write that M is HI by H naught, which is V by U. Again, it's a general formula. When you use this numerical, you have to use sign convention. This is valid for all type of lenses, for all type of images, all type of objects, it's a general formula. So when you use in numerical, use sign convention. Note this also. Note down this question and write your answer in chat room. The simple formula-based numerical on lens formula, calculate the image distance, magnification, height, and nature. Please write answer of all 4 parts simultaneously in the chat room. Don't write, send me the answer of one part. Just calculate all 4 parts and write the answers of all in a single message. So nature of image means real or inverted, sorry, real or virtual, inverted or erect, magnified or diminished. This is what you have to decide in the nature of image. Do it, please. The very simple application based on lens formula. Do it and write your answer in chat room. Okay, Anshika got some answer. So, Anshika, your answer is first part is correct. Second is wrong, Anshika. Check your calculations again. First is correct. First, second, third. Okay. Yes, Suni, all parts are correct. Anshika, just check your second part. First is plus 20. Yeah? Please check the second part and the third part. Yes, Akshay, all parts are correct. All parts. Yoshika, in the part second and part third, there should be a negative sign in your answer. Second and third part, there should be a negative sign. Yes, Anshika, it's correct, but there should be a negative sign in your answer. It won't be plus, it will be minus. Yes, no, all parts are correct. Sakina, Nazia, Krishna, Munib. Krishna, are you solving it?
Yes, I sent them.
Okay. Good, Krishna, all parts are correct. Sakina, Nazia, answers.
Sir, I have sent you, sir.
You have sent me or you have sent to someone else. See, I am the co-host. Send to the co-host, not to host. Yes, good, Sakina. All are correct. Okay, so does anyone have doubt in the first part of the question? Noha, Safullah, does anyone, Krishna, any doubt in the first part? See, your object is placed at 20 centimeters. So your object distance is minus 20 centimeters. You're going in a direction opposite to that of light. Huh? Focal length is a convex lens. That means focal length is positive. You just substitute. So 1 by V minus 1 by U is 1 by F. 1 by V is 1 by F plus 1 by U. Just substitute the value of F and U. Get 1 by 10 is minus 1 by 20. Your V comes out to be 20 centimeters. Now, when we calculate magnification, so magnification is V by U. So V is 20, U is minus 20. So this 20 and minus 20 will cancel out and you get minus 1. So the magnification is minus 1. So V and U, when you divide V and U, they get cancelled out. You get M equal to minus 1. And if you want the height of image by height of object is M. So height of image by height of object, M is minus 1. So height of object is 2. So height of image is minus 2. So see, your magnification is negative. That means your image is inverted and real. Here the mod of M is 1. 1 means it's the size of image and object is same. So that is simple application based question. Gautam, clear? Nazia?
Yes, sir.
Yes, sir.
So it's a very simple problem. Then in the next problem, you will have a number of lenses. So we'll solve those type of problems like the image of one lens will act as an object for another, and the image of that lens will act as an object for another, and keep on solving it. So let's do that type of question where you have multiple lenses. It's not this. Okay. Can I scroll it or anyone is writing this solution?
Done, sir.
Everyone have written up to here?
Yes, sir.
Yes, sir.
Okay, let's do a question which have, this is again a very small thing. Yeah, that's an interesting question. So see, the question says you have converging rays. So converging rays are falling on a convex lens if focal length of lens is 37, what is the position of image? So if there is no lens, then these rays will converge over point A. Means if you don't have this convex lens, then these rays would have converged over this point O. He's asking, but due to convex lens, where this will converge, where they should converge. So you can say that this O will act as an object. The rays are converging, Nabil, so this will be a real object or a virtual object?
Sir, real.
No, virtual. So if you have a converging rays, that means your object is virtual. For image, it could be a real image. But if rays are converging, then your object is virtual. So this is your virtual object O. The object distance is 10 centimeter. If you have a real object, then rays will diverge from the object. If you have a real object, then ray will come out from this object. It will diverge. If it is converging, that means a virtual object. And the focal length of the lens is 30 centimeter. Get the value of image distance. Do it fast. So object distance will be negative or positive in this case, Yashika? U will be plus 10 or minus 10?
Sir, plus.
Why plus? Why not minus?
Because it is in the direction of the light,
right.
incident
Right.
light.
Yeah, right. We are going from optical center to object. We are going in the direction of light. So use forward. Do it. It's a very small calculation. Do it, please, fast. So you have object distance, which is plus 10. You have focal length, which is plus 30. Just use lens formula and get the value of V. How much is V? Calculate V and write your answer in chat room fast. Sorry.
Sir, the image is real, right?
Well, that depends what value of V you are getting. That
No,
simply
sir, from
depends.
the diagram.
From the diagram, you can't decide about the image. You can decide only about the object. You can say that your object is virtual, but nothing about the image. See, we can draw a ray diagram only after your calculations. If your V comes out to be positive, that means they are converging in the forward direction. But if your V comes out to be negative, that means rays are diverging. So how this ray diagram will be will depends on your answer, final answer. V is unknown, so don't use any sign convention for V. Keep it neutral, keep it positive. If it comes out to be positive, that means you're going your image is real. If it comes out to be negative, that means your image is virtual. Krishna, what's the value of V you're getting? Oh, very good. No, I got the right answer. Simple application of lens formula. Very good, Yashika. Your object distance is +10. Your focal length is 30. I'm just asking about the image distance. That's it. Good, good, Nabil. This is just one line calculation. It's easier than the previous question. The previous question, you at least have to calculate many terms, but this is just one line calculation. Just use lens formula. Very good, Sakina, Unip, Nazia, it's right. Bhishma, Akshay. Good, Akshay. See, it's a simple calculation. Now we'll use 1 by V minus 1 by U is 1 by F. So 1 by V is 1 by F plus 1 by U. F is 30, U is 10. Just take it to be 30 by 4 is 7.5. This is easy. This is an easy calculation. Let's do one more question where we have multiple lenses. That will be an interesting calculation. So for those, we'll do it together. Huh? For the multiple lenses, you will calculate the final image distance. So let's do the next question. You can get a similar question on the concave lens also. Huh? So what does plus 7.5 means? It means that rays are converging in the forward direction. So it means your rays after refraction will converge somewhere here. So someone was asking about the nature of the image. So it's a real image or a virtual image, Nabil?
Sir, I didn't ask. It's a virtual and direct image.
No, the rays are actually
Real.
converging. If the
Real
rays are
image.
yeah, image is real and it has to be inverted if it's real. Let's do another question. This is easy. This. Let's do this question. This is interesting. So in this question, you have three lenses. One convex lens, focal length 10 centimeter. Another concave lens, focal length minus 10 centimeter. Another convex lens, focal length 30 centimeter. This is your object placed at a separation of 30 centimeter from the first convex lens. The separation between the first and the second lens is 5 centimeter. The second and the third lens is 10 centimeter. Draw this ray diagram and we'll do it together. Huh? We'll do it one by one. We'll solve one lens at one time. So the logic is simple. The image of first lens will act as an object for the second lens. The image of second lens will act as an object for third lens. This is how we solve these type of problems. Draw this diagram. For the first lens, take your object distance to be 30 centimeter, focal length to be plus 10, and get the value of image distance. Do it. Calculate V1. Solve first lens. Huh? First lens is the convex lens. See, object distance is 30. Nazia, it will be plus 30 or minus 30?
Minus 30, sir.
Minus 30. Focal length is 10. Just apply lens formula and get the value of image distance. Do it. But first, draw the diagram. Huh? So why did it draw the complete diagram? So what is the image distance for the first lens? Write your answer in chat room. Just apply lens formula. Good, Akshay. Akshay got the right answer. What about the rest? Object distance minus 30, focal length 10, get the value of image distance. Very good, Noha. Nazia, just check the sign. Huh? It should not be minus 15. It should be plus 15. Just check your sign. Nabil is correct. Sakina is correct. Yashika correct. See, for the lens 1, just substitute U is minus 30. F is 10. So 1 by V is just 1 by V minus of minus 1 by 30 is 1 by 10. So you get V by V is 2 by 30. So 30 by 2 is 15. So image distance is 15 centimeter.
Sir, could you just scroll a little bit up?
So that's plus 15. So for the first lens, the image is at 15 centimeter. 15 centimeter means from here it's 15. 5, 10, 15. Means the image of first lens is at the optical center of the second lens, third lens. And this image of the first lens will act as an object for the second lens. So Hishma, what is the object distance for the second lens? Hishma. Hishma is not. Akshay, what is the object distance for the second lens?
Negative 15.
No, see, from here to here it's 15, okay? And here to here it's 5. Then how much is this distance? How much is left?
10.
How
10.
much? 10.
10.
See, over to this third lens, now it's 15. You calculated that image distance is 15. The separation between first and second lens is 5. So this separation between the second lens and the third lens, that's 10. So the object distance is 10. You're going in the direction of light, is a virtual object. U2 is positive, plus 10. Focal length is minus 10. Get the value of V. Do it fast. Get the value of V for the second lens first. Then we'll solve the final lens. Hishma, are you still in class?
Yes, sir.
You calculated the first part, this V?
Yes, sir.
Okay. Do it fast. Just get the value of V now. Very good, Nazir. Do it fast. Just put U equal to this thing. How much is U? U equal to this plus 10. Just put U equal to plus 10 for the second lens. No, it won't be 1, 0. It's 1 by 0. 1 by V is 1, 0. Na? So V will be 1 by 0. Good, Sakina. Very good, Akshay. It's infinite for the second lens, na? U is 10, F is minus 10. So just put 1 by 10 minus 1 by 10. It's 1 by V, 0. V comes out to be infinite. Good, Nabil, it's infinite. So for the second lens, the image distance is infinite. And the image of second lens is acting as an object for the third lens. Now repeat the calculation again for the third lens and tell me what is the image distance for third lens. I believe third lens is easy. The image of the second lens is acting as an object for the third lens. Nazia, very good, Nazia. Correct answer. Yes, Nabil, it's correct. Very good. Writes again as a correct answer. See, if for the second lens your image distance is infinite, that means for the third lens also the object distance is infinite. Na? Good, Akshay. Because the image of the second lens is acting as an object for the third lens. So the rays which are getting parallel, so they will act as an object for the third lens. You can say that. See? For the third lens, U is infinite, F is plus 30, so we'll get F equal to plus 30. Or you can do it directly. Infinite rays means parallel rays, where they will converge at the focus. So focal length is 30, that means your image is. Is it clear? Ishma, Munib?
Yes, sir.
Yes, sir.
So that was about lenses. In the next class, now we just one very small topic of refraction, and that is combination of lenses, just a formula. So the next class we'll start the optical instrument and see how much we can cover. So the major portion of the ray optics is over. There are just three small topics. One is optical instrument and is dispersion. But the major chunk was this refraction, which is over. So class is over. If you have doubts, we can discuss, or I'm sharing the assignment of the lens also. This